This is shuttle launch control at T-minus 3 hours and holding. Work inside the Launch Control Center here at the Kennedy Space Center and out at Pad 39B is continuing to move along on schedule towards supporting a launch of Columbia and the STS-58 Space Lab Life Sciences 2 mission on time at 10:53 this morning. The launch team here in the firing room and at Mission Control in Houston are currently tracking no problems. The communications box, which caused us a delay on Friday's planned liftoff, has been removed and replaced, and the new unit has checked out fine. The team moving along right along the schedule here this morning. Our tanking operation, the loading of 528,000 gallons of cryogenic fuels, began as planned this morning at 2:16 and wrapped up just about a half hour ago, or about an hour ago, at 5:12 a.m. The 7 astronauts have been awakened and are in the process of heading towards the breakfast table. The crew will be eating shortly, and after that we'll have a weather briefing from Houston Flight at the Johnson Space Center. They're scheduled to leave the operations and checkout building at about 7:38 today and should arrive at the launch pad at about 10 minutes after 8. The SLS-2 mission is planned to be 14 days in duration, and if all goes as is now scheduled, it will be the longest space shuttle flight in the history of the program. Landing would occur on November 2nd at Edwards Air Force Base. To date, the longest mission was STS-50, which flew from June 25th to July 9th of 1992. That mission lasted 13 days and 19 hours, whereas this flight of Columbia would be 14 days and 29 minutes. Weather here at the Kennedy Space Center is considered to be quite favorable for supporting launch. The forecasters are calling for a 90% chance of good conditions, and likewise we have 3 good sites overseas at the transoceanic abort landing sites. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. The 7 STS-58 astronauts have now convened around the breakfast table at the operations and checkout building. Here we have payload specialist and veterinarian Marty Fettman will be making his first trip in space today. Payload commander, mission specialist number 1, Dr. Ray Seddon. Our STS-58 commander is John Blaha. Sitting on the right-hand seat of the orbiter is pilot Rick Searfoss, mission specialist Dr. David Wolf, mission specialist number 4, Dr. Shannon Lucid, Lieutenant Colonel Bill MacArthur, mission specialist number 2. Astronauts were awakened about 40 minutes ago, and following this pre-flight meal, will be headed next door to don their flight suits in preparation for launch, and they're thumbs up and ready to fly. The launch team obviously hoping the third time is the charm for Columbia and STS-58. The STS-58 mission patch was designed by the astronauts, as are the patches of practically every space shuttle flight. The names of the 7 crew members can be seen flanking the outside of the patch. On each side of the patch, in between the astronauts' names, are these insignias of the veterinary and medical fields. This represents our veterinarian Marty Fettman and our doctors aboard, as well as the medical and life sciences experiments to be conducted on SLS-2. The curlicue signs outside of the orbiter represent DNA, the source of life here on Earth, a building block of life. The space shuttle can be seen clearly in the picture with the number 2 embedded over the Space Lab module, and the orbiter is flying into the Space Lab Life Sciences insignia. Underneath the shuttle orbiter, the United States can be seen quite clearly, representing the fact that this is a U.S. mission. We continue to track no significant issues here within the firing room and out at the launch pad. The astronauts will be donning their flight suits in about another 20 minutes and should head out to the launch pad shortly thereafter. At T-minus 3 hours and holding, this is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding. Work out at launch pad 39B is moving along very nicely. The 7-member ice inspection team is out at the pad and on the 0 level, or the mobile launcher platform level. They're in the process of wrapping up their inspection of the vehicle. What their work entails is taking the elevator up to the top of the launch tower, walking out onto the platforms, and inspecting the vehicle with binoculars and thermal imaging scanners and other devices which are used to observe and detect any unusual or exceptionally thick ice buildups that might be on the external tank or on the boosters or even on the orbiter itself. These ice buildups come as a result of the loading of the cryogenic fuels, of which you can see venting off around the ice team. The cryogenic fuels were loaded beginning at 2:16 this morning, and the operation typically takes 3 hours and was wrapped up at 3 a.m. today. Or I'm sorry, at 5:12 today. While on the 0 level, the 7-member ice inspection team is more concerned with debris on the mobile launcher platform, along with the actual hookups of the orbiter to the external tank around the 17-inch disconnect area, any unusual ice buildups that may have occurred there. The infrared temperature scanners they use provide surface temperature measurements of the external tank and the orbiter itself. By knowing the temperature of the tank, the exterior temperature, we're able to detect any frost buildups or ice buildups that might be observable by the naked eye. The ice team leader is Greg Katnick. Katnick is an engineer from the Kennedy Space Center, while other members of the ice team include engineers from the Johnson Space Center, a safety person from Lockheed, and an inspector from Martin Marietta Corporation, which builds the external tank. Greg Katnick has been reporting his findings back here to the firing room to our NASA test director, Bill Dowdell, and reporting that nothing looks unusual and that he thinks he's going to have a clean vehicle here and a good report when they come back in the next half hour or so. Here in firing room number 3 of the Launch Control Center, work is proceeding just about as well as it could be at this point in the countdown. The team not working any issues of significance that would affect this morning's launch. And again, the prime activity this morning was the fueling operation, which began at 2:16 and was wrapped up at 5:12. The 7 STS-58 astronauts were awakened at about 5:30 and sat down for breakfast about 25 minutes ago. In about another 10 minutes, they will be receiving their pre-launch weather briefing from flight controllers at the Johnson Space Center near Houston. Following that, they will head to a room next door to their crew quarters and begin being outfitted in their flight ascent gear. Again, we continue to move right along the timeline, very much on schedule towards liftoff of Columbia and STS-58 at 10:53 a.m. Eastern Time today. With 43 minutes left in this planned build and hold at T-minus 3 hours and holding, this is Shuttle Launch Control. Meanwhile, the 7 STS-58 astronauts have been receiving a weather briefing from the Space Meteorology Group at the Johnson Space Center. And the forecast for here at Kennedy, as well as our overseas contingency landing sites, all look very good and able to support liftoff today. Local weather at the Kennedy Space Center is forecasted to be excellent launching conditions, with light winds coming from the northwest, switching around to the northeast a little bit later on in the launch window. The meteorology group in Houston is forecasting no rainstorms or any chance of precipitation during our 2.5 hour launch period today, with the only concerns being a possibility that some stratocumulus clouds that are now just off the Florida coast, that they may move in and give us some low cloud decks. But other than that, conditions are looking good here at KSC. Over at Edwards Air Force Base, which would be our contingency once around orbit landing site, the weather is also looking pretty favorable. The only concerns at Edwards might be crosswinds, which are now pushing around 12 to 14 knots, which is close to the crosswind limit. Northrop White Sands in New Mexico, we have a chance of rain showers there, and that site is being ruled out as a contingency landing site at this point. Overseas at the transoceanic abort landing sites, the weather is also looking to be acceptable. Both the Morón site in Spain and Ben Guerir Airport in Morocco are showing good weather systems, and both of those areas are reporting clear skies. Zaragoza is going to be a marginal site. It is probably going to be go and no-go throughout the period, with the concerns there being low clouds and also occasional rain. However, we only need one good TAL site to launch, and there has not been a selection of the prime site at this point yet, but chances are it will either be Morón Air Base in Spain or the Ben Guerir Airport in Morocco. No significant issues being worked at this time in the firing room that would impact liftoff at 10:53. We have good weather. The astronauts are in the process of beginning their suit-up operations, and following that are scheduled to go out to the launch pad at about 7:38 this morning. They should begin boarding Columbia at 8:08. We have 21 minutes left in this build and hold at T-minus 3 hours and holding. This is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding. We have just over 14 minutes left in this build and hold at T-minus 3 hours. In the operations and checkout building, the STS-58 flight crew are donning their flight suits in preparation for this morning's launch. Our commander is Colonel John Blaha, giving us a thumbs up and signaling that he's ready for flight today. This will be the 4th trip in space for Colonel Blaha. Payload specialist is Dr. Marty Fettman. This will be the 1st trip in space for Dr. Fettman, who also has the distinction of becoming the first veterinarian to make a shuttle flight. His primary purpose on this mission will be the care and handling for the 48 rodents flying on the Space Lab Life Sciences 2. Here's mission specialist Dr. David Wolf, wishing everyone a good morning and gearing up for his first flight in space. The orange pressure suits the astronauts wear are actually altitude pressure ensembles that include communications gear as well as a helmet and gloves and other emergency essentials. Mission specialist number 2 is Bill MacArthur. Bill is a lieutenant colonel in the Army and has served as a CAPCOM or capsule communicator in the Johnson Space Center among his duties since becoming an astronaut in 1990. This will be the 1st trip in space for Lieutenant Colonel MacArthur. And here's our payload commander and mission specialist number 1, Dr. Ray Seddon, giving us the A-OK sign and a thumbs up. This will be the 3rd trip in space for Dr. Seddon, who also, aside from her astronaut duties, serves as an emergency room physician in Houston hospitals. Columbia's pilot is Rick Searfoss, and this will be the 1st trip in space for Rick. Our mission specialist number 4 is Dr. Shannon Lucid, obviously very relaxed this morning. The astronauts are assisted in the donning of their suits by technicians who have worked with the crew since the time they were selected for this particular flight. Back out at launch pad 39B, the fully fueled Columbia stands poised for flight. The sun beginning to rise along the Central Florida coast. And we have a clean vehicle out at the launch pad. Here in firing room 3, the launch team has been monitoring their consoles steadily since yesterday evening at 8:33 when the countdown clock was resumed at the T-minus 11 hour and counting mark. This is the 3rd launch attempt for STS-58. The 1st attempt came Thursday, October 14th and was scrubbed at T-minus 31 seconds due to a problem with a computer processor within a console on the Range Control Center over at Cape Canaveral Air Force Station. That problem was able to be corrected in just a few number of hours, and we tried another launch attempt of Columbia the following day on Friday, October 15th. That launch was officially scrubbed at the T-minus 9 minute mark due to a problem with a transponder, a communication S-band transponder aboard the orbiter Columbia. On Saturday, the 16th of October, we changed out that particular unit and retested the new unit, and it worked just fine. We've also changed out the time-critical life sciences samples within the Space Lab Life Sciences 2 module, including 48 new rodents, which are now aboard the ship. And it puts us down to the point where we're now just about 3.5 hours away from the launch of Columbia on STS-58. We have 9 minutes left in this build and hold, and we stand at T-minus 3 hours and holding. This is shuttle launch control. This is shuttle launch control at T-minus 2 hours, 59 minutes and counting. We have just exited our planned build and hold at the T-minus 3 hour mark and continuing to move along a timeline that would result in a liftoff of Columbia and STS-58 at 10:53 this morning. The 7 STS-58 astronauts are now suited in their pressure ensembles, and within the next 5 minutes are scheduled to begin the trip out to Launch Pad 39B. This will be the 15th flight in space for Columbia, which was the very first space shuttle, originally launched on April 12, 1981. And we have a live video shot of our 7 STS-58 crew members as they leave their crew quarters en route for the elevator. Our Director of Flight Crew Operations, David Liesma, and our T-38 and Shuttle Training Aircraft weather pilot, Jim Weatherby, accompanying the crew members. Once again, as it has on the last 2 launch attempts of STS-58, this morning's planned liftoff coincides with the arrival of many first shift employees here to the Space Center, and we typically have a good crowd for astronaut walkouts. Crew being led out by Commander John Blaha and Dr. Ray Seddon, our payload commander. It is approximately a 10-mile trip from the operations and checkout building to Launch Pad 39B, and there has been 30 minutes allotted in the timeline for that travel. En route to the launch pad, the Astro van will make a stop at the intersection of the Saturn Causeway and the Kennedy Parkway to allow our weather pilot, Jim Weatherby, to leave the vehicle and begin his trip over to the shuttle landing facility. The Astro van will also stop at the Launch Control Center to allow our Director of Flight Crew Operations, David Liesma, and other members of management to leave the vehicle. While the astronauts are now traveling to the launch pad, the clock is continuing, counting down towards a planned T0 at 10:53 this morning. Our fueling operation began on time at 2:16 a.m. today and was wrapped up at about 5:12 a.m. Likewise, the ice inspection team, the 7-member crew that looks over the entire launch vehicle as well as the launch structure and the mobile launcher platform, has completed their pre-launch inspection and reported no expected anomalies and a very clean looking vehicle. It has been a very smooth and mostly trouble-free countdown here since the countdown clock resumed at T-minus 11 hours yesterday evening at 8:33. Over the last several minutes, we have picked up one problem with a TACAN, or a tactical navigation aid, on the Shuttle Columbia. This is one of 3 such devices. And these onboard TACANs are used for the external navigation of the orbiter and for the shuttle during the entry phase and return to launch site abort phases of flight. These tactical air navigation units are used to determine the slant range and the magnetic bearing of the orbiter to a specific ground station. We do have 2 good units. 2 of the 3 are up and running fine, and the launch commit criteria specifies that you only need 2 good units. So at this point, it appears not to be a showstopper. We are continuing to troubleshoot this TACAN number 2, and what we're really looking to find is to make sure that there's no correlation between the problems we're seeing in this unit and the other 2 units. Specifically, we're looking to see that this unit is not dragging down or affecting the performance of the other 2 TACANs. This problem was picked up about 20 minutes ago, and again, it's not expected to be a showstopper today. Although we do want to get the unit up and running if possible, we are prepared to launch without it, as flight rules only specify you only need 2 of the 3 units to launch. Other than this issue, the communication channels here in the firing room have been very quiet, and likewise out at the Mission Control Center in Houston, they have been quiet there. Weather this morning at the Kennedy Space Center is considered to be near ideal for launching the space shuttle. We have clear skies. Light winds out of the northwest expected to flip around to the northeast during our launch window. Will not be a concern for a return to launch site abort, should that become the case today. Likewise, overseas, we have at least 2 good transoceanic abort landing sites of our 3 potential sites. The only landing site in question is Zaragoza Air Base in Spain, which is seeing occasional rain showers. The Morón site in Spain is forecasted to be go, as is the Ben Guerir Airport in Morocco. Ben Guerir Airport is likely to become our prime transoceanic abort landing site here this morning. At T-minus 2 hours, 51 minutes and counting, this is Shuttle Launch Control. The Astra van now moving past the Launch Control Center and the blast danger area, which is located about 3 miles from the pad, and on their way to Launch Pad 39B. To clarify the issue over the tactical air navigation unit we're looking at, this is TACAN number 2, and this particular unit has not been operating along the lines of what we'd like to see. It's actually reading a little bit below specifications. We're troubleshooting the unit and primarily looking to see that it is an isolated incident with this particular unit and that it's not affecting the other 2 TACANs. Flight rules specify that you need 2 of these tactical air navigation units to commit to launch, and at this point we do have 2 good units. We are still working to bring the 3rd unit online, but again are concentrating now on making sure it is an isolated incident and that it is not bringing down the other 2 units. Other than this issue, we are looking at no other problems that would hinder this morning's launch at 10:53. Weather is considered to be good here at the Kennedy Space Center. It's good overseas at our transoceanic abort landing sites, and likewise it's acceptable across the United States at Edwards Air Force Base, California. The astronauts now on their way to Launch Pad 39B, and the countdown clock is continuing to tick at T-minus 2 hours, 45 minutes and counting. This is Shuttle Launch Control. This is shuttle launch control at T-minus 2 hours 41 minutes and counting. The Astro van has now arrived at our northernmost launch pad 39B. The 7 crew members are leaving the vehicle and now beginning their trip up the elevator and eventually to the 195-foot level, where we have our orbiter access arm and entry into the shuttle Columbia. This is shuttle launch control at T-minus 2 hours 35 minutes and counting. The 7 astronauts have now arrived inside the White Room, which is located at the 195-foot level of the launch tower. Astronaut and STS-58 Commander John Blaha, the first crew member to arrive in the White Room, and taking off his mosquito netting. The 7 astronauts wore mosquito nets over their head because of the rain we've received in the recent several weeks here at the Space Center. The launch pads are essentially located in a swampy or marsh area and are bordered on the north by a lagoon, which is incidentally named Mosquito Lagoon. The launch pads were originally constructed in the 1960s with dredge fill and concrete, which was brought in to build these pads for launching the Saturn V rockets, which are the vehicles that were used to transport astronauts to the lunar surface. Weather here at the Kennedy Space Center is considered ideal for a launch this morning. We have clear skies. Temperatures are forecasted to be in the low 80s, and winds are currently very light out of the northwest, expected to flip around to the northeast. Commander John Blaha will be the first crew member to board the shuttle, and once inside Columbia, he will be outfitted with his communications gear and immediately begin configuring the vehicle for this morning's flight and initiating contact with flight controllers at the Johnson Space Center.
OTC CMPS. Go ahead. I can give you step 501, ET liquid level, sensor checks during replenisher complete. Copy.
This is shuttle launch control at T-minus 2 hours, 25 minutes and counting. At launch pad 39B, the 7 STS-58 astronauts are continuing with their ingress into the shuttle orbiter Columbia. Commander John Blaha has already entered the vehicle and is in the process of getting settled into his commander's seat on the left-hand side of the flight deck. Columbia's pilot is Rick Searfoss, and he's in the process of being outfitted with his gear he will wear on ascent. We seem to have received some good news over the last few minutes. The problem with the Tactical Air Navigation Unit, otherwise known as TACAN number 2, seems to have been caused by some external noise in the area of the Space Center. We powered down all 3 of the units and brought them back online, and then locked the units onto the airfield at Patrick Air Force Base, and we showed 3 good units were up and running, and they were reading within limits. So the problem seems to be corrected at this point, and engineering personnel here are in the process of talking the issue one last time, but a closure of the problem is expected. Once this issue is put to rest, the team will be looking at no problems that would affect today's liftoff at 10:53 Eastern Time this morning. Weather here at the Kennedy Space Center is very good, as is the weather conditions overseas at the transoceanic abort landing sites. At T-minus 2 hours, 27 minutes and counting, this is shuttle launch control.
Hello, Steve. Can you hear me? Yeah, I'm going to come on over in about 30 seconds and pick up a floppy of the Tape 7 and the Raywan D, and I'll see you shortly. Take care. Bye. OTC CNSC. Go NSA. Can I have the CMQC that was working IPR 0123 come over to 173, please? CMQC, do you copy? CMQC, copy. steps 446 through 452. Copy. OTC, good morning. How do you read? You're loud and clear, John. Good morning. Glad you could join us, Pam. NTD, CDR, how do you read? CDR is NTD on Air Ground 1. Got you loud and clear, John. How many? Loud and clear. Glad you're with us today. I'm glad to be filling in. Hope we can do it today. We will. Houston, Columbia, how do you read?
Good morning, John. Houston has you loud and clear.
You're loud and clear, Kurt. Good morning. It's beautiful weather here.
Yeah, it looks like a really nice day down at KSC.
CGN, COTC. Go ahead, sir. We do it on our gyro line.
This is shuttle launch control at T-minus 2 hours and 21 minutes and counting. Columbia's pilot Rick Searfoss now entering into Columbia, while payload specialist Dr. Marty Fettman is assisted with the outfitting of his flight gear.
Yeah, you've got to go for term idle at this time. Copy. And you can just go ahead and proceed with your IRAM's indication.
Dr. Fettman's primary role during this mission will be the care and handling of the 48 rodents, which are now stowed inside the Space Lab module.
How do you read me, sir? Very good. Just a reminder, we've got somebody talking on 212, and I don't think they belong there.
Marty Fettman has a doctorate degree in veterinary medicine and also a doctorate of philosophy degree in physiology. He's a board-certified veterinary clinical pathologist and has taught and studied at several universities within the United States and at a university in Australia. He was chosen to be the payload specialist for the Spacelab Life Sciences 2 mission last year and has taken a sabbatical from his teaching job at the University of Colorado to train at the Johnson Space Center and to serve as payload specialist for the 14-day-long STS-58 flight.
OTC DPS. Go ahead. I wonder if I can get a QC on 152 to pull taper and prep for GMT adjust. CMQC, OTC, 152.
I copy. OTC, CGMC.
Go GMC.
495, 496 complete.
Copy that. And 497.
That's 497. We'll go for the Delta adjust.
And DPS, OTC. Go ahead, OTC. Perform GMT and MET adjust. Copy. .499 complete.
OTC, 56.
Go.
Yes, did you get the line item 224 have been deferred on the constraints?
Thank you. OTC DPS. Go ahead, DPS. I can give you sequence 16, step 556. CMT, MET, adjust complete. Copy. OTC, COSC. Go ahead. RCS command status test is complete. You've got to go to proceed with posting rest switch reconfiguration. I copy that. And CGNC OTC. Go ahead, sir. 5:57 for the clock. Okay, thank you. OTC, air to ground. Go ahead. Okay, you've got to go to perform your post-ingress switch configuration and switch guard removal per your checklist. Copy. OTC, PLT, com check. Good morning, Rick. I read you loud and clear. How may? You're loud and clear also, Brian. Good morning. Yes, sir. It's a beautiful day for a launch. Guys, third time's the charm. I hear you. CMQC, step 481. PLT, com check. PLT is NTD on air to ground 1. Got you loud and clear, Rick. How many? You're loud and clear also, Mike. I guess you let Al go on his honeymoon? Al is on the honeymoon, has not yet called in to get a status, but I'm sure he'll hear the launch. Okay. Houston, PLT, com check. Houston, PLT, com check.
Good morning, Rick. Houston has you loud and clear. How me?
Got you loud and clear also. Kirk, good morning. OTC, CBS 8212. Go ahead. Step 573 is not performed today. Thank you.
OTC 481 through 494 complete. 504 through 511 complete.
This is shuttle launch control at T-minus 2 hours, 9 minutes, and counting. Mission Specialist Dr. David Wolf and Mission Specialist number 1 and Payload Commander Ray Seddon are now inside the White Room atop the 195-foot level at Launch Pad 39B. Our STS-58 commander and pilot, as well as Payload Specialist Marty Fettman, have already boarded the ship and are in the process of beginning voice checks and configuring the flight deck for today's launch. Shuttle Weather Officer Ed Priscillic has spent the last few minutes updating our launch director, Bob Seek, on his forecast for this morning's launch, and it continues to be a very favorable one. Ed Priscillic is looking at temperatures in the low 80s with scattered clouds and winds to be light and out of the east-northeast. The only concerns would come a little bit later in the afternoon, well into our launch window, when he sees the possibility for some towering cumulus clouds, those clouds that can cause lightning or inevitably the effects of triggered lightning were we to launch near them. He sees the potential for those clouds building up in the early afternoon. Today's launch window opens at 10:53 a.m. and closes at 1:17. And if we stick to the timeline that we are now on and have been proceeding by for the last several hours, these cumulus clouds would not be a player in today's launch at 10:53. The incident surrounding a suspected faulty tactical air navigation unit, otherwise known as TACAN number 2, has essentially been put to rest. We attribute the problems we saw with that TACAN to external noise that could have been reverberating off the iron launch tower and affecting the readings we were seeing off the TACAN. No other issues being talked on the loops that would affect today's launch at 10:53. Weather is good and the vehicle looks fine. At T-minus 2 hours, 7 minutes and counting, this is shuttle launch control.
OTCS.
Go ahead.
Post ingress switch reconfig complete. We're going to go to master alarm tripping while we adjust the icon volumes.
I copy. And ISL, do you copy?
ISL copy.
ISO copy. OTCS.
Go ahead.
Icon volume adjust is complete. Parameter selected at 120.
I copy. And QC 513 through 570 complete.
Copy.
GLS OTC. Go ahead, sir. Can perform GLS initialization for the clock. Copy, and first step 559, FEP dual interrupt notification will be activated momentarily, and if we can get a CMQC on channel 162, please. CMQC?
I copy 162.
CGSS OTC. GSS will perform force charge this time, if that's what you're requesting. That's firm. Okay. OTC GSS. Go ahead. Yes, sir. 564, 65, and 66 are complete. I copy. RSRT, OTC. RSRT, OTC 212. RSRT, go. Okay, 575, you can load new tape. Copy, that's in work. OTC, RSRT. Go ahead. Step 575 is complete. Tech is 2009. 2009, copy. CGNC, OTC.
Go ahead.
How are we doing with IMUs?
We're in platform positioning, and we'll take the IMUs back to term idle and put the at-dead in work at 1 hour and 59.
This is shuttle launch control at T-minus 2 hours and holding.
578,
Mission Specialist number 2, Lieutenant Colonel Bill MacArthur, is now being assisted with his flight gear.
Manual 575.
This will be the first trip into space for Colonel MacArthur. He became an astronaut in 1990 and has previously served as a capsule communicator with other shuttle crews up on orbit.
OTC, COSC.
Colonel MacArthur is a graduate of West Point, but also graduated from the Navy's test pilot school. He is flying on this mission as a mission specialist and will be participating in many of the scientific experiments aboard the Space Lab Life Sciences 2 mission. But he is certified and qualified to fly as a pilot of a space shuttle mission. This is shuttle launch control at T-minus 1 hour, 57 minutes and counting. We now have 5 crew members from STS-58 aboard the shuttle Columbia, and mission specialist number 2, Bill MacArthur, is readying to board the ship. A lot of activity has been ongoing here in firing room number 3 of the Launch Control Center for the last several minutes. Some of the highlights of these activities included the activation of the ground launch sequencer program in the integration console here in the firing room. Engineers are currently setting up the tables in the launch processing system that the ground launch sequencer will use as its guideline for allowing the launch countdown to continue. Other recent activities include the pressurizing of the main propulsion system's helium tank, as well as activation of the solid rocket booster's hydraulic power unit gas generator heaters. We've also just completed checks of the liquid fuel levels inside the shuttle's space external tank, and those are all checking out fine. Once all of the crew members are aboard Columbia, they will begin conducting air-to-ground and air-to-air voice checks with our launch controllers here at the Kennedy Space Center and flight controllers at the Johnson Space Center. There are no issues of note being worked by the launch team, nor flight controllers at the Johnson Space Center. Weather is holding out and looks to be very favorable this morning. And at T-minus 1 hour, 55 minutes and counting, this is shuttle launch control.
MS1, com check.
You're loud and clear, Ray. Good morning.
Good morning, Brian. This is going to be the day.
That's it.
NTD MS1, com check.
MS1 is the NTD on air to ground 1. Got you loud and clear, Ray. How many?
Hey, Mike, weren't you here for SLS1?
I'm sorry, MS1?
you hear for STS-40, Mike?
STS-40 was a good one. I hope we do it today. I think we had 3 attempts on 40 too, didn't we?
Yep, there's a charm, thanks. Houston, Columbia, MS1, com check.
Good morning, Ray. Houston has you loud and still nominal.
And the same to you, Kurt.
CGNC OTC.
Go ahead.
Yeah, you've got to go for a gyro compass alarm for the clock.
Thank you.
589.
Thank you.
Mission Specialist number 2, Bill MacArthur, thanking the closeout crew for their work and now entering into the Shuttle Columbia. Mission Specialist number 4 is Dr. Shannon Lucid. Shannon's a veteran of 3 other Space Shuttle missions, and on this particular flight will be heavily involved with the life sciences research. Launch preparations continuing to move very much along the timeline here this morning as we ready our last member of the STS-58 flight crew for entry into Columbia.
OTC, OVCC. Last crew members boarding at this time.
Copy.
Mission Specialist number 4, Dr. Shannon Lucid, now entering the vehicle and becoming the 7th and final crew member aboard Columbia. A few weeks ago, the STS-58 astronauts sat down to talk in detail about their specific functions and the importance of many of the experiments flying aboard the Spacelab Life Sciences 2 mission. Here, 3-time space veteran and mission specialist number 4, Shannon Lucid, talks about one of the cardiovascular experiments to be conducted on the mission.
And one thing that we'll be doing will be echoing the heart. And echo is a procedure that you commonly use. It's a very common tool that's used in your doctor's office. A lot of people are very familiar with it because it's the echo machine that you look at when you're pregnant to see whether the fetus is developing normally. Well, we'll be doing that in the heart. We're using, and the echo machine uses sound waves and makes pictures of the heart. And when we get into microgravity, when we get up on orbit, where gravity is no longer pulling the parts of our body down in the way that it has all our life, but the different parts of your body then tend to be redistributed, just like we were talking about the fluid that gets redistributed. So your heart comes up just a little bit, it rises up, and then your heart sees that it doesn't need to work quite so hard, so it begins to change the amount of volume of blood that it's processing. And we'll be taking pictures of all this, and then the investigators will be able to look at it and from these pictures make calculations just to see how much the heart does change over the period of time that we're in flight.
Medical doctor and mission specialist David Wolf is anxious to learn more about the physiological changes in space in hopes of helping others here on Earth.
By rationally understanding the physiologic changes that occur in space, we then rationally design countermeasures to these disturbances, and then look at each countermeasure in terms of its impact on the other systems again to make sure we haven't, by fixing one area, made the rest worse. I guess in medicine we all realize that every treatment is simply replacing one disease with another, and our goal is to replace a worse disease with a less worse disease, and that's our goal. We don't expect to make man who adapted on Earth all these years to be better off or even as well off in space, but we can improve the situation a good deal.
Mission specialist Bill MacArthur is involved in an experiment that may help astronauts avoid problems with dizziness that have been experienced on past missions.
There will be something slightly different about the lower body negative pressure device this time. Dr. John Charles has spent a lot of time working on it, and most of the flights up until this time have been in a sort of data gathering, developmental nature. We've put astronauts in the LBNP device to see, in fact, if we can quantify and understand how the body responds and if, in fact, it responds as predicted. The commander, John Blaha, and I will be LBNP subjects, and a couple of times during the flight we will just ramp up to a fairly high pressure, negative pressure in the device to see how our body responds, and then the day before landing we'll actually be in the bag for approximately 4 hours, in which the bag is trying to pull fluids back down into our legs and lower extremities. At the same time, we're going to ingest salt tablets and a large quantity of water to try to get the body fluid level closer to what it was when we launched than it is normally after a long space flight, hoping that that will assist us in maintaining appropriate blood pressure levels as the body changes. So the difference for STS-58 is LBNP is beginning to transition into an operational countermeasure. So we're beginning to transition from studying and seeing if it works to trying to actually implement it as a countermeasure.
Payload specialist and veterinarian Marty Fettman will be devoting much of his time and attention to the study of the 48 rodents flying aboard Columbia.
I can speak for myself, and I don't want to sound like I'm speaking for a profession or any organization. these are my personal feelings about it. I am very concerned about the use of animals in research. I think I have a reputation in my profession as having been concerned and active in trying to reduce the use of animals. And so I fully acknowledge that there are folks out there who don't agree with the use of animals in research. There are others who would like to see it reduced and would prefer that we not use those animals. And I will admit that there are some people who see no problem with it. I guess I fall in the group in the middle, that I would love to not have to use animals for research. I think that would be just the best world possible. But unfortunately, there are outstanding medical questions that need to be answered that I personally believe are vital to the future of humanity, and certainly in this case to the future of space exploration. And so if we accept that space exploration is something we still want to accomplish, and that there are medical questions that are still important to the health and safety of any future explorers, then I see using these animals in this particular way as the only way of solving some of those problems.
Medical doctor and space veteran Ray Seddon flew aboard the first Spacelab Life Sciences mission and speaks about a vestibular system experiment to be conducted on this flight.
There's another experiment that we do of the vestibular system that looks at the reflexes. When you jump or when you fall here on the ground, there are reflexes in your vestibular system that says, uh-oh, I'm falling and I need to catch myself, and it sends messages down your spine to the muscles in your leg. And that's called the vestibulospinal reflex, and the leg muscles tighten to catch yourself. There's some evidence that in weightlessness, that reflex, again, gets out of shape because you're no longer falling, and the vestibular system is no longer giving you good information. And we think that, once again, the whole system gets a little confused. And so what we're doing is we attach ourselves with some suspenders to the floor, and we do a sort of a pull-up onto a bar, and then the bar drops us, and then we measure the reflexes down in the muscles of the leg to see how quick that reflex is, because it's nothing that you think about. It goes too quickly for your brain, your upper centers, your thinking centers to be a part of it. It's a pure reflex. And so when you do this, you're testing out all of the receptors that tell you you're falling, and the spinal reflexes that tell you how to catch yourself. And we're trying to see whether or not that slows down. It's important for you when you come back to Earth, because again, if you hop off the shuttle, you'd like to know that your legs are going to be underneath you, or you'd like to know that that reflex is a little rusty and you better be careful.
Houston, MS2, com check.
Good morning, Bill. Houston has you loud and clear. How me?
Loud and clear, Kurt. Unfortunately, I think all our fellow Tar Heels are thinning out down here.
Well, we'll try to get you off today.
systems on 212. The spa will be out of operation for approximately 5 minutes.
This is shuttle launch control at T-minus 1 hour, 36 minutes, 42 seconds and counting. The launch control team here in firing room 3 continuing to closely monitor the state of the vehicle at the launch pad, as well as the Space Lab module located inside the payload bay of Columbia. The communications channels within the firing room continue to remain relatively quiet, with no problems of any significance being worked by the launch team at this time. The astronauts are aboard Columbia and are scheduled to begin voice checks within the next minute. These voice checks are with the launch control team here in firing room 3 and also with our mission controllers in Houston. Weather continues to look very favorable here at the Kennedy Space Center, as well as across the ocean at the transoceanic abort landing sites, Morón Air Base in Spain, and Ben Guerir Airport in Morocco. No other issues of note being reported, and the countdown continues at T-minus 1 hour, 35 minutes and counting. This is shuttle launch control.
OTC, MS3, com check. Hi, Brian.
MS3, this is OTC. Dave, I've got you loud and clear.
I also have you loud and clear. NTD, MS3, com check. Hi, Mike.
MS3 is NTD on Air Ground 1. Got you loud and clear, David. Good morning.
Good morning. I also have you loud and clear. Houston, Capcom, MS3, com check. Hello, Kurt.
Good morning, Dave. Houston has you loud and clear.
I also have you loud and clear.
This is shuttle launch control at T-minus 1 hour 25 minutes and counting. Out at the shuttle landing facility, our weather pilot, Jim Weatherby, is wrapping up his observations with the T-38 aircraft, and will soon be leaving that aircraft and head over to the shuttle training aircraft, which is a modified Gulfstream II that has been configured to fly very much like the Space Shuttle does on approach and landings.
You're loud and clear, Marty. Good morning.
Good morning, Brian. Let's go do it.
Copy that.
NTD, TS for com check.
TS1 is NTD on Air Ground 1. Got you loud and clear, Marty. How many?
Mike, you sound great. Good morning.
Good morning.
Houston, this is TS for com check.
Good morning, Marty. Houston has you loud and clear. How many?
Same here, Kurt. Good morning to you.
OTC MS4, com check.
You're loud and clear on out, air to ground 1, Shannon. Good morning.
And good morning to you. MS4, com check.
MS4 is NTD on air to ground 1. That's loud and clear, Shannon. How many?
And I've got you loud and clear also. Houston, MS4, com check.
Good morning, Shannon. Houston has you loud and clear. How me?
And I've got you loud and clear also.
OTC, CGLS. Go GLS. GLS initialization is complete. Step 661. Copy. And CDR OTC on air to ground. Go ahead, OTC, CDR. Looks like we have everybody loud and clear on air to ground 1, ready to do the Astrocom checks. Roger that, sir. We are ready. All systems on 212 will be picking up with our Astrocom checks. Any conversation on OIS 212 will be heard by the crew. The channel should remain silent except for emergency calls. Go ahead and proceed. Air to ground 1 roll call. Columbia OTC, air to ground 1, how do you read? CDR, loud and clear. PLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
Yes, loud and clear. Okay, I've got all of you loud and clear, proceeding to air to ground 2. CDR, loud and clear. PLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
Yes, loud and clear. CDR, loud and clear. PLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
Yes, loud and clear. CDR, loud and clear. PLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
Yes, loud and clear. DC, com check on air to air. CDR, loud and clear. PLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
Yes, loud and clear. I copied all of you loud and clear, and they'll take care of my com checks. I'm going back to air to ground 1. Houston, CDR, OTC, air to ground 1.
OTC, CDR.
John, we're doing a launch poly update here. It'll be just a minute. We'll be picking back up with the Astrocom checks.
Okay, we'll stand by.
.94 through 606 complete.
Columbia, Houston, we are now ready for the MCC air-to-ground voice check. CDR and POT configure for air-to-ground 1 comm checks.
That's in work, Houston. Houston, Columbia is configured for air-to-ground 1.
Columbia, Houston, with a comm check on air-to-ground 1. How do you read?
CDR, loud and clear. PLT, loud and clear.
Columbia, Houston, we read you loud and clear. Configure for air-to-ground 2 comm check.
That's in work, Houston. Houston, Columbia is configured for air-to-ground 2.
Columbia, Houston, this is a comm check on air-to-ground 2. How do you read?
CDR, loud and clear. PLT, loud and clear.
Columbia, Houston, we read you loud and clear. Configure for UHF comm check.
That's in work, Houston.
CMQC, OTC.
Go ahead, OTC.
Need somebody on 142, please.
Copy 142.
Columbia, Houston, this is a comm check on UHF. How do you read?
CDR, loud and clear. PLT, loud and clear.
Columbia, Houston, we read you loud and clear. Configure for SIMO voice checks.
AFM, go ahead.
That's in work, Houston. Houston, Columbia is configured for SIMO voice check.
Columbia, Houston, this is a comm check on SIMO air-to-ground 1, air-to-ground 2, and UHF. How do you read?
CDR, loud and clear. PLT, loud and clear.
MS1 loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4 loud and clear.
Yes, loud and clear.
Columbia, Houston, we read you all loud and clear. This completes the air-to-ground voice checks.
OTC, ASP.
Go ASP.
ASP verifies that all non-flight items are removed and ASP is ready to go off the headset and egress the crew module.
Okay, we have one more EORF status we'd like to take care of, Don.
Copy.
And let me know when you're in position.
And go ahead with the EOR.
Okay, power switch to power.
Verified.
Mode normal.
Verified.
Excel enable.
Verified.
Refrigerator freezer refrigerator.
Verified.
Alarm alarm switch enable.
Verified.
Temp control knobs plus 045 equal on.
Verified.
Plus 035 equal off.
Verified.
Freon leak LED off.
Verified.
Cabinet press LED off.
Verified.
And the temp display, please.
Temp display is 04.0 degrees centigrade.
Copy, 131750.
This is shuttle launch control at T-minus 1 hour, 15 minutes and counting. The flight crew aboard Columbia at pad 39B have now completed their air-to-ground voice checks with mission controllers at the Johnson Space Center and the NASA test director and orbiter test conductor here in Firing Room 3 at the Kennedy Space Center. The shuttle Columbia was the first member of NASA's 4-member orbiter fleet and was initiated in the program back on April 12th of 1981. In the 12.5 years that have passed since that first flight of Columbia, the ship has consistently proven itself as an invaluable member of the space transportation system. Aside from the 2 launch postponements we experienced last Thursday and Friday, this flow of the STS-58 mission has gone extremely well with Columbia, and the vehicle has pretty much sailed through all of its pre-mission processing leading up to this morning's launch at 10:53 Eastern Time. The reusable Space Lab module, now inside the shuttle Columbia, last flew in September of 1992 on the Space Lab Japan mission. The Space Shuttle Columbia last flew in spring of this year and landed at Edwards Air Force Base, California in early May. That 14th flight of Columbia was also a Space Lab mission and a cooperative venture between the United States and Germany. After arriving back at the Kennedy Space Center, Columbia was towed into an orbiter processing facility, and the Space Lab module was moved to the Operations and Checkout building, where it underwent pre-launch integration and checkout. There are several racks inside the Space Lab module. Each of these can be instrumented with various experiments, and each rack is capable of holding up to 600 pounds. Some of the equipment and hardware now located inside these racks include spectrometers, incubators, and rotating domes and chairs that will be used for the mission's many life sciences experiments. The Space Lab module is about 14 feet in diameter and roughly 23 feet long. The Space Lab Life Sciences 2 mission is a joint venture between the Johnson Space Center, the Kennedy Space Center, Ames Research Center, and the Marshall Space Flight Center. This past spring, the STS-58 astronauts paid a visit to the Kennedy Space Center and went inside the Space Lab module for a checkout of the equipment and experiments that they will be using the next 2 weeks in space. These inspections are a standard part of the flow of every space shuttle mission and give the astronauts an opportunity to see the flight hardware that they will be using during their flight. Mission Specialist Ray Seddon looking at some of the racks that she will be using over the next 2 weeks. Columbia was transferred to Launch Pad 39B on September 17th. The launch pad is about 3.4 miles away from the vehicle assembly building, and the vehicle travels out to the launch pad aboard a crawler transporter. a large tractor-like vehicle which moves at an average speed of about 1 mile per hour when the orbiter is atop it. The crawler transporters have been used at the Kennedy Space Center for more than 20 years and were the transport vehicle for the giant Saturn V rocket during the Apollo era. The Space Shuttle Columbia and mission STS-58 now poised and ready for liftoff.
OTCC, Jetsy.
This is Shuttle Launch Control at T-minus 1 hour, 6 minutes and counting. At Launch Pad 39B, the members of the closeout crew are in the process of closing Columbia's hatch for flight. Following the completion of this procedure, our commander, John Blaha, will initiate commands within the orbiter to do air pressure leak checks of the vehicle. Here in the firing room 3 of the Launch Control Center, we're tracking no problems that would affect launch.
Go ahead.
The weatherman is cooperating this morning, and we have forecasts that we will have go weather at launch time. Scattered clouds, temperature in the low 80s, and light east to northeast winds. Out along the NASA Causeway, we have thousands of spectators, guests of NASA, who have been invited out for the launch. And hopefully today will be the day that we will get to see liftoff of Columbia and the start of the STS-58 mission. The countdown continues at T-minus 1 hour, 7 minutes, 23 seconds and counting. This is Shuttle Launch Control.
In work. OTC, CPVD 212. Go ahead. Leeward vent door opening complete at step 185, 184. I copy. OTC, OVCC. Go ahead. Yes, hatch is closed, latched, seal leak check's good, latch continuity is good. We're ready for 2 PSID leak check. Copy that, can work. CECL, OTC. This is CCL. Ready to pick up with cabin leak checks. Copy that. CMQC, need to verify 654.
Stand by, let me get that.
And ECL, if you're ready, we'll proceed with 2 PSID leak check. ECL's ready. Just want to inform the CDR about the master alarm. We'll need notification when that happens. Sure will. CDR, OTC. Go ahead. Okay, we'll be picking up with the cabin leak checks at this time. A note, the master alarm and light will come on as a function of the high cabin pressure. If you could let us know when that happens. May get klaxons as well. You can reset.
Okay, I copy that. You want me to put the cabin leak check in work now?
That's affirmed. You can go ahead and configure the vent isolation valve, vent isolation switch to open until you get the talk back.
That's in work.
OTC, CMQC.
Go ahead.
Yeah, I do not have that off support set up complete, part C.
Okay. The only thing that was left was the hatch to be closed, and the hatch is obviously closed if you look at camera 5.
Copy, and that gives us the complete...
And OTC.
That's affirmed. Go ahead, CDR.
Roger, the cabin leak check is complete.
And ECL, did you verify 657? Oh, we can verify that. Okay, ECL and OVCC, you can go ahead and proceed with 658. ECL copy. OVCC copy. OTC, ECL. Go ahead. We're ready for a CDR reading of cabin press on panel 01. CDR, OTC.
Roger, the cabin press is 14.7.
ECL copy, thanks.
This is shuttle launch control at T-minus 59 minutes and counting. Workout at the launch pad continuing to go very well. The closeout crew has locked and closed the orbiter's hatch in preparation for flight, and our commander, John Blaha, has been initiating leak checks of the vehicle to make sure it is flight worthy. Communication continues to be at a minimum amount within the firing room here, as the launch team is working no problems that would impact today's launch of Columbia on time at 10:53 this morning. That launch window extends out until 1:17 p.m. if we were to have any problems crop up between now and launch time. Today's launch will be the 58th flight in the history of the shuttle program, a program that began 12.5 years ago on April 12, 1981, with the first launch of Columbia. Over the last couple of minutes, we've been pushing on with our pre-launch operations. The pre-flight alignment of the ship's inertial measurement unit was begun a few minutes ago, and our shuttle training aircraft pilot Jim Weatherby is likewise preparing to continue his flight operations out at the shuttle landing facility. The STS-58 mission is dedicated to life sciences, and the prime payload is the Space Lab Life Sciences 2 module. As such, we have dozens of experiments flying aboard this mission that concentrate specifically on medical research. But we are flying another unique experiment on this mission, one called Pilot, for Portable In-Flight Landing Operations Trainer. This particular experiment was devised by a shuttle training aircraft research pilot at the Johnson Space Center. Charlie Justice, who is the co-principal investigator of this experiment, recently took a few moments out to demonstrate how the pilot program works and to talk with the media at the Kennedy Space Center about his experiment, which is now aboard Columbia.
Back in September of last year, General Pearson, the head of the Office of Spaceflight up in headquarters, made it a task for us to develop an on-orbit trainer which would be used to maintain astronaut pilot proficiency following extended stays in space. A small team was formed at the Johnson Space Center that consisted of engineers, pilots, former astronauts, and some headquarters folks as well. And we came up with the Portable In-Flight Landing Operations Trainer, or Pilot. This simulator can fly from 0.95 Mach after a deorbit on down to nose gear touchdown, and so far we've gotten pretty high marks from it. We had Frank Culbertson fly it following his landing, and he said it flew just like the orbiter pretty much until you get close to the ground, so we're quite pleased with the results so far. And also you can see here it gives the STA traces that the astronauts are used to, so they get the feedback that they want.
You want to try a run? Sure. This is shuttle launch control at T-minus 56 minutes and counting. Our shuttle training aircraft pilot, Jim Weatherby, now taking off on his first run of the morning in this modified Gulfstream II aircraft. Weatherby has been flying a little earlier today in a T-38 jet, and he's mainly flying to the north and east boundaries of the Space Center, looking for any clouds that might be a concern to our commander, John Blaha, were we to have a return to launch site abort after launch today. The forecast from the meteorologist here at the Cape Canaveral Air Force Station is a favorable one, and it's one in which Jim Weatherby has been concurring with their observations that the clouds are indeed scattered and would cause no visibility concerns to Commander Blaha if he were to have to come back to the shuttle landing facility today shortly after launch. The only concern we're looking at as far as weather would be a potential for crosswinds out at the shuttle landing facility, and that is one of the reasons that Jim Weatherby is now out flying that shuttle training aircraft so that he can inform our weather coordinator Mike Baker here in the Launch Control Center, as well as the flight controllers in Houston, about how the shuttle training aircraft is behaving, as it would be indicative of the type of behavior that the shuttle would experience on a return to launch site abort. No problems of note being reported by the launch team or mission control or the astronauts aboard Columbia. The countdown continues at T-minus 54 minutes, 9 seconds and counting. This is shuttle launch control.
No, we have no constraints at this time.
Copy.
LTC, CCSC back on 212.
Copy, CCSC. CCME, OTC. CCME, go. Ready for you on 128 for RF step source verification. Copy that, going to 128. 1692 complete.
This is shuttle launch control at T-minus 51 minutes, 56 seconds and counting. Our booster test conductor, Phyllis McGrath, has just verified that we have correct chamber pressure inside each of our 2 solid rocket boosters. Sensors inside these boosters measure the pressures inside the thrust chambers of each particular booster. The data from these transducers is then used to tell the flight computer when to jettison the boosters away from Columbia. The solid rocket boosters ignite at T0 and burn for about 2 minutes and 2 seconds, at which point they are jettisoned away from the orbiter and parachute back down to the Atlantic Ocean. NASA has 2 solid rocket booster recovery ships which have been on station since yesterday, and they are located about 8 miles from where our anticipated splashdown points would be of the 2 boosters. Following a launch, the boosters are recovered. Water is pumped out of the nozzle end of the boosters, and they are then righted into the horizontal position and towed back into the port where they're recovered. Just about 2 minutes ago, our NASA test director, Mike Leinbach, has stated that our S-band communication system has been moved over to the high configuration and that it is ready for launch. Thousands of workers and tens of thousands of man-hours go into preparing each space shuttle for its particular mission. Columbia's vehicle manager, Grant Cates, recently took a few minutes out to talk about some of the work that has been involved in this flow.
Hi, I'm Grant Cates, NASA Vehicle Manager for the Space Shuttle Columbia here at Kennedy Space Center. Today, Columbia is being transferred to Launch Complex 39B, where final preparations and launch will take place. Columbia landed at Edwards Air Force Base in California at the end of her last mission, STS-58. Following post-landing safing activities, Columbia was mated to the shuttle carrier aircraft, a modified 747, and flown to the Kennedy Space Center. During the ferry flight, an Air Force C-141 flies ahead of the shuttle to make sure that we do not fly through any adverse weather. Once at Kennedy Space Center, the shuttle was removed from the shuttle carrier aircraft and towed into the Orbiter Processing Facility, the OPF. In OPF Bay 2, hundreds of tasks had to be performed to prepare Columbia for the SLS-2 mission. All of the thermal protection tile, blankets had to be inspected and repaired or replaced as required. Each of the orbiter's fluid, mechanical, and electrical systems were given a complete and thorough checkup, and any anomalous parts were replaced. The extended duration orbiter pallet was also installed. This pallet consists of liquid hydrogen and liquid oxygen storage tanks and allows Columbia to stay on orbit for as many as 16 days. The STS-58 mission is currently scheduled for 14 days, with 2 days available for any contingencies. Columbia is the only vehicle to fly this pallet thus far, and she currently holds the on-orbit record 13 days, 19 hours during STS-50. One of the highlights of the stay in the OPF is a crew equipment interface test. This test, which occurs after the space lab has been installed and the orbiter is in a near flight configuration. During this test, the astronauts perform hands-on inspections and operations of the space lab and the orbiter systems just as they will on orbit. After Columbia was rolled out of the OPF, she was transferred to the Vehicle Assembly Building and mated to the external tank. Performing this work in the OPF is a shuttle processing contractor, the Lockheed Space Operations Company. They, together with government and other contractor personnel, perform the truly remarkable and complex task of preparing Columbia for flight. The Columbia processing team looks forward to a successful STS-58 mission.
This is shuttle launch control at T-minus 46 minutes, 56 seconds and counting. All continuing to go well here at the T-minus 46 minute mark. A couple of minutes ago, pilot Rick Searfoss configured the switches to pre-activate the orbiter's 3 water spray boilers. Each of Columbia's 3 hydraulic systems has a water spray boiler that cools down hydraulic fluid and auxiliary power unit lube oil. During the launch, re-entry, and landing phases of the flight, the water spray boilers are activated if the hydraulic fluid temperatures exceed 208 degrees Fahrenheit or if the lube oil temperature exceeds 250 degrees Fahrenheit. The water spray boilers are located in the orbiter's aft fuselage, and each one of these boilers holds about 14 gallons of water.
We'll probably get a master alarm and klaxon for the DPDT.
We're standing by now to begin our terminal countdown range safety closed loop test. This is a test that verifies the channels the destruct signals would travel and that Columbia's range safety receiver is responding to the system check. A few minutes ago, we did receive confirmation that the orbiter's S-band communication system has been placed in the high power mode in preparation for today's launch.
DPS go. You can perform a launch countdown sequence.
The S-band system is used to transmit and receive voice data and telemetry information from the ground. The system itself is quite flexible and works either through the ground tracking stations or through the tracking data and relay satellite system. The launch team is working no problems of any significance here. The weather seems to be good for this morning's launch. The vehicle appears to be in fine shape, and we're now at T-minus 44 minutes and counting. This is shuttle launch control.
OTC GLS. Go GLS. Yes, sir. GLS mainline activation is complete. Steps 733 through 738. And on step 735, we can put an X in the bypass column for IMU hold available timer activation. Copy. IMU hold timer activation.
OTC DPS.
Go ahead.
I can give you 753. All steps complete.
Copy. OTC CCL 212. Go ECL. Yeah, the initial cabin leak check is complete at this time. We're ready for the cabin vent redundancy configuration. Copy that. And CDR OTC perform cabin vent redundancy configuration.
Roger, and work. OTC, CDR, cabin vent redundancy configuration complete.
I copy. ECL. ECL copy.
This is shuttle launch control at T-minus 35 minutes and counting. Within the last couple of minutes, we've had a few more milestones reached in the countdown here. Commander John Blaha has reported back to Orbiter Test Conductor Brian Monborn that he has completed leak checks of the Shuttle Columbia. And with that accomplished, the closeout crew will begin coming back to the roadblock about 3 miles away from the pad. The Superintendent of Range Operations over on the Cape Canaveral Air Force Station has also informed our test director that the range is ready for launch, which signals that the downrange shipping stations are clear, that the booster splashdown area is open, and all necessary downrange support is up and standing by for this morning's launch at 10:53. In about 2 minutes from now, Shuttle Weather Officer Ed Priscillic will brief Launch Director Bob Seek and other members of the management team on his current observations as well as his forecast for this morning's launch in just about 1 hour. There are no issues of note being tracked by the team in the firing room. And at T-minus 37 minutes, 52 seconds and counting, this is shuttle launch control.
OTC, OVCC.
Go ahead.
Yeah, hatch closeout is complete, ready to continue with white room closeout.
You've got to go to proceed.
And OTC is CCL 212.
Go ahead.
And the final cabin leak check is complete at this time. Ready to start, Ben.
Ready for that. I copy that. ACD, OTC.
Yes, ACD.
Acknowledge step 759. We'll be venting into the orbiter payload bay and aft.
Okay, copy that.
ECL 758.
Yeah, reading negative 0.001.
I copy. CDR, you may get a klaxon and a master alarm, and you can reset, and you've got to go to open the cabin vent isolation valve.
That should work. OTC, CDR. Cabin vent is incomplete.
I copy that. And ECL, do you acknowledge 765?
That's firm.
OTC, CCSE.
Go ahead.
Can I get TRPS on 155, please?
RPS, OTC. 155.
OTC, OVCC.
Go ahead.
Yeah, environmental chamber closeout is complete. All equipment has been returned to closeout locker. We've accounted for all of our tools. We're ready to leave the pad.
Okay, I copy. And stand by for just a second.
Copy.
OTC, CGSS. Go ahead, GSS. Yes, sir. Could you have them security O2 monitor there in the white room?
Copy, will do.
And CDR OTC, perform pass BFS transfer prep.
Roger, pass, BFS transfer prep in work.
And OVCC OTC.
Go ahead.
Okay, if you can check the slide wire baskets, make sure they're positioned, and take care of the elevators.
This is shuttle launch control at T-minus 31 minutes, 30 seconds, and counting.
And I can verify we have 7 baskets.
The closeout crew relaying to our NASA test director here that they are finished with their job at the pad and ready to leave the white room and the launch structure and head back to the blast danger area, which is about 3 miles away from the launch pad.
Aye, copy.
About 1 minute ago, the backup flight control system computer software was installed, or rather initiated for flight, and that's now being configured. In another 45 seconds, the gaseous nitrogen system for the orbital maneuvering system engines will be pressurized for launch. The payload aboard the Orbiter Columbia is the Spacelab Life Sciences 2 module. It is continuing to behave very normally. We're seeing nothing unusual with either the module or any of its power systems or any of the experiments aboard that we're now monitoring. The Space Shuttle Orbiter itself gets a lot of attention, but just as much work and just as much energy and importance is given to readying the Spacelab modules for flight. Spacelab Life Sciences 2 engineer, Carrie Backus, who works at the Kennedy Space Center, has played a key role in preparing the SLS-2 module for its mission.
I'm Carrie Backus. I work for NASA at the Kennedy Space Center. We're here in the Operations and Checkout building at Kennedy, and we're processing the Spacelab Life Sciences 2 mission. We're getting ready to go over to the orbiter processing facility where the module, which houses the experiments, will be integrated into the orbiter. You see it here in the background. There's a lot of activity going on down there. We have some final preparations, some cleaning, and some last-minute checks that we're doing now. I'm in the experiment integration group. I'm a lead mechanical engineer. I've been with NASA 7 years now, and I've been in the experiment integration group the whole time. I started out as a systems engineer and moved up to a lead engineer. I'm responsible for the assignments and direction for the systems engineers that are under me, and I also review documentation, drawings, and procedures in order to ensure that the payload is integrated correctly and completely. The SLS-2 payload is about the same as the SLS-1 payload, which also flew aboard Columbia just over 2 years ago. A couple of differences between the payloads is the experiment upgrades on SLS-2. Also, we've doubled the number of rodents from SLS-1 to SLS-2. And there's been an addition of a standard interface rack, or SIR. The SIR will be used on Space Station Freedom, and it will provide a standard interface between experiments and the ESA racks. ESA is the European Space Agency and are prime partners with the United States in Space Station Freedom. ESA provided the Space Lab module, which houses the SLS-2 experiments. More than 100 people have spent the last year devoting their time and efforts to get the SLS-2 payload ready for flight. The team here at Kennedy enjoys working with the flight hardware, but we also enjoy working with the people that are associated with the experiments. The principal investigators, experiment developers who design and develop the experiments, and also the astronauts who will spend the next 2 weeks operating the experiments. The payload team has taken a lot of pride in getting the Space Lab module ready for STS-58. We're looking forward to a successful mission and great science.
And CDR, stand by for SIMO air-to-ground voice check.
CDR, standing by.
OTC, COFC. Go ahead. Yeah, 785 through 789 complete. Copy.
Columbia, Houston, we're ready for our air-to-ground voice check. This will be a SIMO voice check. How do you read?
CDR, loud and clear. TLT, loud and clear.
MS1, loud and clear.
MS2, loud and clear. MS3, loud and clear.
MS4, loud and clear.
TS, loud and clear.
Columbia, Houston, we have you all loud and clear. John and Rick, we have a new altimeter for KSC of 30.03.
Roger, copy, 30.03.
And that's a good readback, John. We also have an update to Ben Guerrier altimeter, 30.12. And after that, I have the updates to your first stage trajectory on page 8-5 in your checklist when you're ready.
Okay, we have the 30.12 standby.
OTC, CGLS, GLS limit change and dual notification for BRS QRS is complete. Step 798. Copy.
Houston, Columbia, we're ready to copy 8-5.
Columbia, Houston, 8-5, max rates, first stage, roll, positive 1.2 degrees per second at 5 seconds. Pitch, positive 1.0 degrees per second at 7.2 seconds. Yaw is less than 1 degree per second. Max EAS is 450 at 50 seconds. Trajectory lofting, second stage is NA. You will be 0 nautical miles on lofting or depression.
Houston, Columbia, copies all. Thank you, Kurt.
CPVD, OTC, 212.
CPVD, go ahead.
You did go on 823.
PVD copies and work.
This is shuttle launch control at T-minus 24 minutes, 6 seconds, and counting. STS-58 Commander John Blaha completing air-to-ground voice checks with flight controllers in Houston and showing that we do have a good communication system today. Within the last few minutes, the orbital maneuvering system gaseous nitrogen tanks were pressurized for launch and are now being checked out.
Normal purge configuration.
We use gaseous nitrogen to operate the valves which allow the hypergolic propellants to flow into each of the two orbital maneuvering system engines. These are the engines that allow us to change our orbit while up in space and also to adjust the orbit. A bite check, or pre-flight software validation, of Columbia's master events controller has been successfully completed. The master events controller relays commands from the orbiter's computers to fire explosive charges to the solid rocket boosters about 2 minutes after launch.
All personnel is in today. The countdown clock will hold at T-minus 20 minutes.
Also at this time, the primary computer guidance data, which was obtained as a result of the alignment of the inertial measurement units, is being prepared for transfer to Columbia's backup computer. NASA Test Director Mike Leinbach just now announcing to the team that the countdown clock will hold as planned at the T-minus 20-minute mark. This planned T-minute hold is one of 2 remaining. The other hold comes at T-minus 9 minutes, and it is also planned to be 10 minutes in duration. During this hold at T-minus 20 minutes, Leinbach will poll members of his team to assure their readiness to come out of the hold. And we'll also be catching up on any work that we might have gotten behind on during the last few minutes. Presently, though, we're right on the timeline, and there's nothing standing in the way of launch at 10:53 this morning. The weather outlook is good. Ed Brasilic, our weather officer, just informing Launch Director Bob Seek that his only concerns are some clouds that are offshore, and they would only be an issue if they moved into the area of the pad and we had to fly through moisture during ascent. Again, this is not expected to be an issue, and currently there are no obstacles in the way of a 10:53 liftoff. At T-minus 21 minutes, 34 seconds and counting, this is shuttle launch control. This is shuttle launch control at T-minus 20 minutes, 14 seconds, and counting. NASA Test Director Mike Leinbach just receiving the word that the closeout crew, who just assisted the astronauts into Columbia, are now back at the blast danger area, where they will remain throughout today's launch. The countdown clock now stands at T-minus 20 minutes and holding. This is a planned 10-minute hold. And we will now take an opportunity to go to the Johnson Space Center and the Marshall Space Flight Center to assess their readiness for today's launch of Columbia.
CVFS.
This is Mission Control Houston at T-minus 20 minutes and holding. Flight Director Wayne Hale presides over the ascent team this morning, and astronaut Curtis Brown will serve as the crew communicator, calling out the milestones and abort boundaries during the climb to orbit. Just after clearing the tower, Columbia's onboard guidance system will steer the ship through a roll pitch maneuver to set its course for an orbit inclined 39 degrees to the equator. After generating a good head of steam, all 3 engines will be eased back just a bit. As Columbia accelerates through the lower atmosphere, they'll throttle up again to about 104% rated thrust at about 1 minute for the remainder of the ascent. The solid rockets will burn out and fall away at about 2 minutes 3 seconds, and main engines will continue to burn until about 8 minutes 33 seconds. Columbia's orbital maneuvering engines will fire at about 37 minutes after liftoff to circularize its orbit at 153 nautical miles. Here in Mission Control, the team has been keeping an eye on launch and abort landing site weather conditions throughout the morning. The primary transoceanic abort landing site, Ben Guerir, is both observed and forecast go, as is the Kennedy Space Center, both for return to launch site and launch corridor weather, both observed and forecast go. The only area of potential concern, as mentioned, is the possibility of some clouds overhead, but again, flight controllers here don't see that as an issue either. Flight controllers here will continue to watch world weather and monitor critical orbiter systems throughout the remainder of the count. We'll check in now with this SLS-2 Payload Operations Control Center at the Marshall Space Flight Center in Huntsville, Alabama. This is Mission Control Houston.
CDR on 01, please.
This is the Space Lab Mission Operations Control Center in Huntsville, Alabama. Once again, the payload operations team is in place and ready to support the launch of Columbia. When Columbia does make it to orbit, the 7-member crew will start 14 days of medical sciences research. But even before the Space Lab is fully activated, crew members will start collecting blood and taking measurements of the blood pressure near the surface of their skin. In addition to those measurements, Mission Specialist Shannon Lucid and Payload Specialist Marty Fettman are currently wearing catheters to measure the blood pressure in the great veins near the heart. Now, these early measurements are very important because the body begins to adapt to weightlessness immediately. One of the most significant changes is the shifting of body fluids from the lower extremities, which is the normal condition on Earth, to the torso and upper extremities. The body perceives this natural shift as an increase in fluid volume and uses natural mechanisms to set new levels for space. Many of these changes occur rapidly and must be measured as soon as possible after launch. For example, we saw on Space Lab Life Sciences 1 in 1991 that central venous pressure rose while the crew was seated in the launch position on the launch pad and increased further during the launch phase of the flight. Once in space, however, the pressure dropped within 60 seconds and remained low until the catheter was removed. The central venous pressure measurement is only one of the hundreds of biomedical measurements that will take place over the next 14 days, and the payload operations team is standing by to help the crew make the most of their time on orbit. There are no payload issues being worked by the team at this time, and all operators here in Huntsville are ready for launch. We'll now go back to the Kennedy Space Center for continuing launch coverage. This is Space Lab Mission Operations Control.
This is Shuttle Launch Control, where the countdown clock remains holding at T-minus 20 minutes. We have just under 6 minutes left in this planned build and hold. NASA Test Director Mike Leinbach has just instructed all console operators to switch over to the same communications channel. This is a channel they will be following and monitoring for the remainder of today's launch countdown.
Okay, when the flight's ready.
Our Landing and Recovery Director, John Guidi, has reported that the shuttle landing facility crew is ready and configured for launch, and that the booster recovery ships are on station and standing by. The launch team here at Kennedy Space Center and at Mission Control Center in Houston are looking at no problems that would impact this morning's liftoff of Columbia at 10:53. Weather is go, and the vehicle is also go.
We'll verify. JBFX.
We have just under 5 minutes left in this planned build and hold at T-minus 20 minutes and holding. This is Shuttle Launch Control.
Personnel is the NTD on 212 and 232 conducting the T-minus 20-minute briefing. Launch window this morning opens at 14:53 GMT and closes at 17:17 GMT. A second launch attempt is possible if a recycle occurs. There are no COLAs for this morning's launch. If a hold is requested and issued between T-minus 9 minutes and T-minus 31 seconds, the countdown clock will be restarted upon successful resolution of that problem without a go survey made of all elements. If the launch cannot be accomplished within the launch window, or the following time is exceeded, the NTD will call cutoff. Our estimate on block strainback hold time is 4 minutes and 47 seconds. TLT at T-minus 5 minutes perform APU start upon command of OTC only.
TLT copies.
CDR, the pad egress system is nominal. Evacuation helipad is number 9.
CDR, number 9.
Flying room test team, disable telephone ringers at this time. Ingress and egress of the flying room will not be allowed after resuming the count at T-minus 20 minutes until after launch or flight crew egress if a recycle occurs. All personnel not active in the terminal count monitor OIS channel 217. All personnel bear in mind that critical post-launch operations will be in progress after successful launch, so please keep flying room noise and activities to a minimum. After T-minus 20 minutes, all problems or trends that require a countdown clock hold must be reported to the NTD on channel 212 together with your recommendations. After T-minus 5 minutes, any hold, manual, or GLS should be accompanied by a description of the problem and your recommendation. The countdown clock will continue until T-minus 31 seconds, however, unless your recommendation to hold at the next milestone is necessary. And the milestones are listed on page 852. And CDR is NTD on behalf of the whole test team. We hope third time's a charm today, and wish you the best of luck on a launch and a successful mission and a good California landing.
Thank you very much, and we want to thank all the people here at the Cape for all the hard work and professional work that they do in getting us ready to launch. We're looking forward to it.
Okay, thank you. Let's go do it today. Are there any comments for the briefing? That concludes the briefing.
NTD, this is Rob.
Go ahead.
Okay, we just want to verify the launch stream back hold time based on performance number.
Our performance was 5 minutes 43, but inlet temps was 4:47.
Copy that.
FCP OTC.
Go ahead.
Yeah, you can perform your fuel cell purge to the clock.
Copy.
TPS, TPE, and ISL OTC.
TPS. ISL.
TPE?
Acknowledge 904, please.
TPE acknowledges 904.
ISL acknowledge.
And DPS acknowledges 904.
All personnel countdown clock will resume at 14:23 GMT.
All systems on 212. After transition to Ops 101, discontinue all LDB PMU reads for remainder of countdown.
Flight NTD 212.
NTD flight.
Will the optional VHF weather circuit briefing be required?
Negative. That will not be required today.
Copy. S10, copy not performed. Copy, sir.
This is shuttle launch control at T-minus 20 minutes and holding. We're just about 24 seconds away from coming out of this planned build and hold at T-minus 10 minutes. Just a few minutes ago, Launch Director Bob Seek received his weather briefing from Shuttle Weather Officer Ed Priscillic, and it was a very favorable briefing.
Countdown clock will resume on my mark.
4, 3, 2, 1. And we're now at T-minus 19 minutes, 59 seconds, and counting. As a result of the weather briefing, the launch director notified Mission Control in Houston that we will be having a nominal hold at T-minus 9 minutes, which would entail a 10-minute duration hold, and we will be going for the opening of the window this morning at 10:53 a.m. A purging of Columbia's fuel cells is now underway, and dumping of computer software from one of the 4 general-purpose computers is just a couple of minutes away from occurring. T-minus 19 minutes and counting. The transitioning to the primary ascent software is now complete, and Columbia's computers are now in the primary launch program, also known as Ops 101.
OTC DPS.
Go ahead.
Pass Ops transition 101 is complete, ready for BFS to 101.
CDR OTC, take BFS to Ops 1 for your checklist.
CDR in work.
T-minus 17 minutes, 50 seconds and counting. And Mission Management Team Chairman Lauren Schreiber just notified that the balloon data is in from the upper level balloons and that our upper winds are good and acceptable for launch today. Dumping of the Ops 101 program from one of Columbia's 4 general purpose computers has now begun. This dumping procedure and examination of the software contents will take about 10 minutes to complete. Also currently, airframe engineer Rob Drescher is checking data to assure that all is well with Columbia's critical aero surfaces in preparation for today's launch. On the flight deck of Columbia,
Ops 1 is complete.
pilot Rick Searfoss is now adjusting cockpit switches to make sure they're ready for flight.
For your checklist.
T-minus 16 minutes, 50 seconds and counting.
NTD, CVFS. NTD, ready for BFS uplink. Copy. Flight NTD, perform BFS pre-flight uplink loading.
NTD flight will put it in work.
And CDR OTC, you can configure contingency aboard yaw steer for your checklist.
Roger, the configuration for contingency aboard yaw steer is complete.
T-minus 16 minutes, and Columbia's pilot Rick Searfoss is now in the process of performing the main propulsion system helium system reconfiguration. This procedure opens the helium isolation valves which are necessary for in-flight purges of the shuttle engines. It also provides an emergency source of pressure for pneumatic shutdown of the main engines, should that become necessary. We have a report that the water levels in the water spray boilers have been checked and verified as sufficient for launch.
NTD flight 212.
Go flight.
BFS pre-flight uplink load is complete, step 934.
Copy. CVFS copy. Copy that.
OTC, PLT, horizontal fit config is complete. Copy, perform MPS helium reconfig. MPS helium reconfig in work. COOS OTC. Go ahead, configure ohms RCS cross speeds for flight.
That's in work.
T-minus 14 minutes, 50 seconds, and configuration of the cross-feed valves
MPS helium reconfig complete. I copy.
between the orbital maneuvering system and reaction control system propellant tanks has been performed. T-minus 14 minutes, 30 seconds, and booster test conductor Phyllis McGrath is now initiating the gaseous nitrogen purge of the aft skirts of the 2 solid rocket boosters.
Flight NTD. OTC double S.
Go.
Yeah, we'll give you step 948 ohms cross feed valves configured for flight.
Copy.
Houston flight NTD.
NTD flight.
Yes, sir. Will we be activating the OEX recorders?
We'll put it in work.
I copy that. And ISL and JRPS copy activate OEX recorders.
ISL copy. JRPS copy.
Thank you. OTC FCT.
Go ahead.
961, fuel cell purge complete, ready for load adjust.
I copy. EPD and ECL, do you copy?
EPD copies.
ECL copy.
T-minus 13 minutes and counting, and we have confirmation that purging of the fuel cells is reported complete and that loading of the fuel system has been adjusted for launch.
And all personnel, the countdown clock will hold at T-minus 9 minutes and approximately 3 minutes.
T-minus 12 minutes and counting, and NASA Test Director Mike Leinbach informing the team that the countdown clock will hold as planned at T-minus 9 minutes.
QC on 145. CMQC?
CMQC. I copy 145.
That's Roger.
We're also seeing signs that we've had a good dump of the T-minus 20-minute dump of the orbiter's general purpose computer memory system. No problems reported there.
OTC, CVFS. Go ahead. T-minus 20 minutes, GPC dump complete with 0 miscompares. Copy.
Houston flight NTD 212.
NTD flight.
Yes, sir. G1 launch poly update. Will that be required?
Negative. That will not be required. Neither will the IMU misalignment correction. So I can give you steps 985 through 995 will be not performed.
I copy. Very good.
T-minus 10 minutes, and we're just 1 minute away from the last of today's scheduled build-in holds planned before the 10:53 launch of Columbia and the second Spacelab Life Sciences mission.
All systems on 212. Discontinue all non-mandatory LDB traffic for remainder of count.
Booster test conductor Phyllis McGrath is now verifying that the hydraulic unit power levels in the boosters are at a proper level for launch.
This is ISL. Yes, sir. Can you give me step 967?
Launch Control Center computers are also adjusting the flow rate of conditioned air being fed into the orbiter's payload bay.
A little bit. Okay, copy.
Just 9 seconds away from our last build-in hold of the day. 3, 2, 1, and we're now at T-minus 9 minutes and holding.
9 minutes and holding.
We're at T-minus 9 minutes and holding, and still have several key milestones remaining between now and liftoff. Once we come out of the hold, the ground launch sequencer will take charge and begin controlling commands and monitoring of shuttle systems for all critical tasks.
The RTLS update, will that be required?
We have one update.
During this period, Mission Management Team Chairman Lauren Schreiber will be pulling members of the shuttle management crew and assessing their readiness for today's launch.
Mode boundaries.
Our launch director, Bob Seek, will also be pulling his management team and checking their support and readiness for today's launch. And at the present time, engineering director Bob Lang is checking with all systems engineers to see that they are ready to come out of the hold at T-minus 9 minutes.
NTD flight, that completes our update for the crew.
Copy. And OTC and STM step 1001. Copy. Copy 1001.
CPVD, OTC, you've got to go for step 1002.
CPVD copies in work. CISL, JRPS, Houston Flight, NTD, activate recorders, CISL.
CISL, copy.
JRPS.
JRPS copies.
And Houston Flight.
Flight copies.
NTD CISL, 967.
I copy. And all systems, this is the NTD conducting a launch status check. Verify ready to resume the count and go for launch. Say go or no go. OTC.
Go.
TBC.
TBC go.
PTC.
PTC go.
LPS.
LPS go.
Flight.
Go.
Mila.
Go.
SDM.
Go.
Safety console.
Safety console, go.
SPE.
SPE, go.
CDR.
Go.
LRD.
Go.
SRO. I copy. Launch director NTD.
Go ahead.
Your launch team is fully ready to proceed.
I copy, and we'll conduct the management poll shortly.
This is Shuttle Launch Control at T-minus 9 minutes and holding. We have 5 minutes left in this planned build and hold of 10 minutes in duration. Our mission management team chairman, Lauren Schreiber, has completed the poll of his management team, and all answers were affirmative.
OTC,
Kennedy Space Center Engineering Director Bob Lang had a similar poll of his engineering team. And our NASA Test Director Mike Leinbach has just had a positive poll of the team here in the firing room. At this point, we're standing by for the final poll of the day by Shuttle Launch Director Bob Seek, at which point we fully expect to come out of the countdown.
Conduct the management poll at this time. Payload operations.
SLS-2 is go, Bob.
Copy, Tom. Engineering Director.
Bob, engineering is go.
Copy. Safety and quality.
Safety and quality is go, Bob.
Copy. Range weather. Launch Director, we have no weather constraints to launch from. I copy, Ed, thank you. And Ops Manager, Launch Director.
Bob, the MMT is not working any issues. You're cleared to launch.
Thank you, sir. Well, it sure looks like a good day to launch, so we'll make a run at it. NTD, you have go to proceed.
Copy, thank you, sir.
OTC, CPVD 212. Go ahead.
Payload bay purge flow rate set for launch. That's step 1003 and 1005. Complete. 1004 will be now performed.
I copy.
All personnel, the countdown clock will resume in 3 minutes. Mark.
This is Shuttle Launch Control. We have just over 2.5 minutes left in this planned build and hold. Launch Director Bob Seek announcing to the crew aboard Columbia and the launch team that we will come out of the hold on time at 10:44 this morning, leading to liftoff of Columbia and STS-58 right at the opening of this morning's window at 10:53. Command of Columbia will transfer to the ground launch sequencer once we exit this hold at T-minus 9 minutes. In just under a minute, the heaters inside the boosters are planned to be turned off in preparation for launch. Booster test conductor Phyllis McGrath is now confirming proper levels of hydrazine are inside each of the booster's hydraulic power units.
Countdown clock will resume in 1 minute. Mark.
NTD, Houston, flight 232.
Go flight on 212.
Sorry, 212. Lock strain back hold time now 5 minutes 39 seconds.
Copy 539.
Copy.
Countdown clock.
We have just 5 seconds left in this build and hold.
2, 1.
And we're now at T-minus 8 minutes 59 seconds and counting.
Sequence has been initiated.
The ground launch sequencer has been activated and the STS-58 terminal countdown is underway. All of the countdown events are now being handled by the ground launch sequencer up until the T-minus 31 second mark, when responsibility for the countdown is handed over to Columbia's onboard computers.
STM NTD 1043, 1044 not performed. Copy.
Okay. NTD, CISL, recorders are activated. Copy. 1007.
I copy, thank you.
PLT, OTC, configure fuel cell essential bus storage switches. That's in work.
T-minus 8 minutes and counting.
OTC, PLT, essential bus source fuel cell switches complete. Copy.
T-minus 7 minutes 30 seconds and the ground launch sequencer has initiated retraction of the orbiter crew access arm away from Columbia. This bridge between the orbiter and the launch tower can be reinstalled back in place within 15 seconds if need be. T-minus 7 minutes, 10 seconds, and counting. T-minus 6 minutes, 30 seconds, and counting.
TRPS OTC, start APU and hydraulic strip chart recorders. RPS can verify recorders are running. PLT OTC, perform APU pre-start.
APU pre-starts in work.
Orbiter Test Conductor Brian Monborn has given pilot Rick Searfoss the okay to perform the auxiliary power unit pre-start procedure.
212, go SRO. Yes, sir, we are no-go for an intruder aircraft at this time. Request you hold the countdown clock. CLS, hold the clock at 5 minutes.
Copy, the countdown clock will hold at T-minus 5 minutes.
And SRO, entity any estimation when it will be clear the area?
Stand by 1 moment, sir.
The countdown clock will hold at T-minus 5 minutes.
OTC PLT APU pre-start complete.
Okay.
3-grade talkbacks.
I copy that. Now just stand by for a second, please.
SRO NTD.
NTD SRO on 212.
Yes, sir, any estimation?
Sir, that situation is cleared. We are go, and you have arranged clear to launch.
I copy. Launch directory, copy?
I copy, and you have go to proceed.
Copy that. GLS, resume the count on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS is go for orbiter APU start. Copy. PLT OTC, perform APU start.
APU starts in work.
Orbiter Test Conductor Brian Monborn has given our pilot Rick Searfoss the command to start Columbia's auxiliary power unit. Once the pilot completes this task, hydrazine will begin flowing into the holding tanks of the orbiter's auxiliary power units.
Heater reconfiguration complete.
OTC PLT APU start is complete. 3 good APUs.
I copy.
Columbia's pilot reporting that we have 3 good APUs. Due to the intrusion of an aircraft into the launch area, launch of Columbia will come 8 seconds late at 10:53:08. T-minus 4 minutes, 6 seconds, and counting.
GLS is go for purge sequence 4.
T-minus 3 minutes, 50 seconds, and a test of Columbia's flight controls is started. These aero surfaces, such as the rudder, elevons, and speed brakes, are being cycled through a programmed test pattern to verify that they are ready for flight. T-minus 3 minutes and 30 seconds, and we are now transferring over to internal power and switching Columbia off of ground power. At this point, the orbiter is being powered by its onboard fuel cells. T-minus 3 minutes, 20 seconds, and counting. T-minus 3 minutes, and Columbia's engines in the final stages of being ready for flight. T-minus 2 minutes, 55 seconds.
Pressurization.
And the external tank's gaseous oxygen vent hood is being moved out of place in the next few seconds. At 37 seconds before launch, the ground launch sequencer will make a final check to assure that the vent hood is positioned well away from the space shuttle.
Verify no unexpected errors.
Caution warning, memory clears in work.
Orbiter Test Conductor Brian Monborn requested pilot Rick Searfoss to clear the ship's caution and warning memory system.
OTC PLT caution warning, memory clear complete. No unexpected errors.
Retraction of the external tank's gaseous oxygen vent hood is now in work.
Close and lock your visors, initiate O2 flow. This time we're going to send you.
Roger that. Closing visors, pseudo-2 on.
Orbiter Test Conductor Brian Monborn instructing the flight crew to close and lock their visors. T-minus 1 minute, 50 seconds, and counting.
1 minute, 30 seconds.
T-minus 1 minute, 30 seconds, and counting. T-minus 1 minute, 10 seconds, and the ground launch sequencer is now checking that Columbia's 3 main engines are ready for ignition. The final word of their readiness should come at about T-minus 10 seconds when ground launch sequencer engineer George Thomas gives the go for main engine start. T-minus 51 seconds and counting. The solid rocket booster heaters have been turned off. T-minus 31 seconds, and we have auto sequence start, and Columbia is now in charge of its own launch countdown. T-minus 24 seconds. T-minus 20. All systems remain go at T-minus 15 seconds.
10. GLS go for main engine start.
Set T-minus 6, 5, 4. We have main engine start. 3, 2, 1. Booster ignition and liftoff of Columbia on a life sciences mission for Earth and space.
Houston's now controlling.
Houston, Columbia, roll program.
Roger, roll, Columbia.
Mission Control sees a good roll maneuver, placing Columbia on the proper heading. 3 good engines at 100%. Engines are throttling back now, easing Columbia through the dense lower altitudes, but continuing to accelerate very rapidly. Columbia is already traveling over 650 miles per hour. Time 45 seconds. All systems are performing well. All 3 engines at 67% rated thrust. And 3 engines are throttling up.
Columbia, Houston, go at throttle up.
All engines are now running at full throttle. All systems performing well. Altitude 67,000 feet. Downrange distance 8 nautical miles. Columbia is traveling over 1,000 miles per hour. Columbia continues to climb at a relatively steep angle at this point, tripling its rate of speed over the next minute. Solid rocket boosters, each delivering 3.3 million pounds of thrust, will burn out and separate at 2 minutes 3 seconds. Time now 1 minute 48 seconds. Altitude 115,000 feet. Downrange distance 18 nautical miles. SRB chamber pressure is tailing off. And Mission Control sees a good booster separation. Columbia is now flying free, powered by its own main engines. Second stage guidance is now in effect. Altitude 184,000 feet, downrange distance 35 nautical miles.
Columbia, Houston, performance nominal.
Roger, Kurt, performance nominal.
That call confirms that the boosters have once again done the job that they're designed to do, and the main engines as well. Altitude now 222,000 feet, downrange 48 nautical miles. Columbia is now traveling over 3,000 miles per hour.
Columbia, Houston, 2-engine Ben Guerrier.
2-engine Ben Guerrier.
Columbia can now cross the Atlantic Ocean with only 2 engines should one fail. Altitude is now 263,000 feet, downrange distance 68 nautical miles. At this altitude, Columbia's flight path is beginning to level out a bit, shedding more and more weight as propellant burns off and continuing its rapid acceleration. Columbia is now traveling over 3,800 miles per hour, altitude 295,000 feet, downrange 85 nautical miles. All systems are performing well, time 3 minutes, 36 seconds.
Columbia Houston, negative return.
Negative return.
A return to the launch site is at this point no longer an option as Columbia continues downrange. Altitude now 352,000 feet, downrange distance 149 nautical miles. Columbia is now traveling nearly 5,000 miles per hour. Three engines are continuing to burn at 104% rated thrust. Good hydraulic system, good electrical systems. Altitude now 367,000 feet. Downrange distance 183 nautical miles. Time 5 minutes 10 seconds. All systems are performing well.
Columbia Houston, press to ATO.
Roger, press to ATO.
Columbia Houston, Droop Ben Greer 109.
Droop Ben 109.
Columbia has gained at this point enough momentum to reach a safe orbit should one engine fail. Altitude's now 381,000 feet, downrange distance 278 nautical miles. Time 6 minutes 5 seconds. All systems are continuing to perform very well. We're standing by for the press to MECO call.
Columbia Houston, press to MECO.
Press to MECO.
Columbia Houston, single engine Ben Greer 104.
Single engine Ben.
Columbia now has enough momentum to make a normal insertion to orbit with only two engines should one fail. Altitude's now 376,000 feet, downrange distance 392 nautical miles. Columbia is traveling nearly 10,000 miles per hour and could now make a transatlantic flight with only one engine should that become necessary. Time 6 minutes 56 seconds.
Columbia Houston, single engine press 104.
Single engine press 104.
Should two engines fail beyond this point, Columbia could still reach a safe orbit with a remaining engine at 104% rated thrust. Altitude is now 366,000 feet, downrange distance 520 nautical miles. Columbia is actually beginning to dip back down into the atmosphere at this point, giving altitude in order to gain velocity as Columbia continues to accelerate towards orbital velocity. Columbia's downrange 590 miles.
Columbia Houston, no action on your fuel cell pH message.
Okay, thank you. We copy that.
Time 8 minutes 10 seconds. Three engines are throttling back now to maintain structural loads within the 3G limit. Just about 15 seconds away from main engine cutoff.
Houston, Columbia, MECO 25. 815, MECO confirm.
Columbia, Houston, we copy. Columbia, Houston, nominal MECO, no ohms 1 required. You are a go for the photo DTO.
Roger, go.
And we have confirmation that Columbia has come off the external tank and is flying free now in an orbit of 148 by 42 nautical miles. As the external tank peels away and begins to fall behind and below Columbia, one of the crew members will move to the overhead windows and attempt to photograph the external tank as it falls back to Earth. Columbia is continuing on in its 149 by 42 nautical mile orbit. That low end of the orbit will be raised with an ohms burn. That burn will serve to circularize Columbia's orbit at 153 nautical miles. Coming up in about 25 seconds, crew of Columbia will be given a go to start the main propulsion system fuel dump. At this point, everything looks very clean. We had a very clean climb to orbit. During the ascent, there was one message received here on the ground from a fuel cell that was producing a pressure indication that was determined not to be an issue. With that exception, a very event-free. As far as anomalous events go, very event-free climb to orbit this morning. Again, Columbia has reached its insertion orbit of 147 by 42 nautical miles. Actually exceeded that just slightly. It looks like they're at about 149 by 42. At this point, flight controllers are making no updates to the pre-ohms 2 plan. They'll be watching as the crew vacuums the main propulsion system of any residual propellants and as they configure the vehicle for ohms 2.
Columbia, Houston, with a comm check, we're locked up hard on T receives.
You're loud and clear.
Columbia, Houston, you have a go for APU hydraulic shutdown on time with the DTO of 312.
Copy, go APU hydraulic shutdown on time, order 312.
Columbia's onboard communication systems are now locked up on the TDRC satellite, providing communications between mission control and the crew aboard Columbia. As well, the crew's been given a go to power down the auxiliary power units. Those units provide hydraulic pressurization to the mechanical systems on board. Those APUs won't be required again until one is restarted the day before entry to test the mechanical systems aboard Columbia before bringing the bird home, and then powered up again with the other two to begin the deorbit and entry procedures on the final day of the flight. This is Mission Control Houston. We're 15 minutes, 25 seconds into the flight of Columbia. The ohms burn to circularize Columbia's orbit at 153 nautical miles has been recalculated now and is going to occur at 42 minutes into the flight, just about 26 minutes away from now. Again, Columbia did just a little bit better than its target insertion altitude. They're currently at 149 by 43 nautical mile orbit and should arrive at their orbital destination in just about 25 minutes.
Columbia Houston, we're showing good cooling on all three APUs.
Copy that.
Columbia Houston, we're showing a nominal ohms 2, and our TIG is 41:55.
Roger. Roger, normal ohms 2 and TIG of 4155. Thank you.
And that maneuver will come just about 22 seconds from now. It'll serve to accelerate Columbia by 198 feet per second, further accelerating the vehicle into its destination orbit of 153 nautical miles circular. At this point, the main propulsion system dump is complete, and the crew will be given a go fairly shortly to begin the vacuum inerting. We're at 20 minutes, 38 seconds, and all systems aboard Columbia are continuing to perform very, very well. There were no issues of note during the climb to orbit this morning. Again, we're working towards an on-time firing of the orbital maneuvering engines aboard Columbia.
Houston, we like the ohms 2 targets. We're going to go ahead and load them.
Columbia Houston, we show good ohms 2 targets, and you have a go to load.
Okay, thank you.
Columbia Houston, John, when you get a chance, we would be interested in a debris report, and also for Ray, for block 14, we do have some deltas for that block whenever you're ready.
Okay, Kurt, stand by on the debris report, and we'll relay that to Ray.
Houston, Columbia from CDR, no unusual debris at all to report out the W3. W2, RW1.
Columbia Houston, John, we copy.
This is Mission Control Houston. We're 26 minutes 38 seconds into the flight of Columbia after a trouble-free climb to orbit. We're now 15 minutes away from ignition of Columbia's twin orbital maneuvering engines, which will serve to raise the perigee and adjust the apogee of Columbia to produce its operational target altitude of 153 nautical miles. At this point, all systems have performed very well. There have been no revisions to nominal crew procedures having completed the insertion, and the upcoming burn will serve to accelerate Columbia by about 198 feet per second into its final destination. Crew's in the process now of cleaning out any residual fuel in the fuel lines of the vehicle, allowing the vacuum of space to draw any residuals out and avoid any contamination due to residual fuels in the lines during the course of the mission. Following the OMS maneuver and reaching their destination altitude, the crew will begin reconfiguring the vehicle's data processing systems and beginning to configure the radiators and the payload bay doors to open them and begin the orbit operations phase of the mission. We can expect all of that activity to get underway in about 25 minutes.
Columbia.
Columbia, Houston, go ahead.
With your go, we'd like to start vacuum inert terminate at TIG -10.
Columbia, Houston, Rick, you have a go for that.
Okay, copy a go.
Columbia, Houston, I have some words on your ohms 2 burn.
Ready to copy, Kurt.
Yeah, John, we're showing an off-scale low with the left ohms PC. We're not sure exactly where it's coming from. We think it may be a deucer. As a heads up, when you do burn ohms 2, you may get a message, left ohms PC in the pass and BFS. Your meter may not work. Also, just as a heads up, if right engine goes down, you'll get both down errors on the system.
Okay, if the Kurt, we copy all of that. We've seen that before in the film, so thank you very much for the information.
That's affirmative, John, and that's just a heads up. Everything may work totally as normal. We were just going to give you a heads up in case that did happen. You know what we were talking about.
Yes, I do. Thank you very much.
Columbia, Houston, we have some switch throws on panel A12 whenever you're ready.
Okay, stand by one. We'll get somebody to get them. Houston, Columbia, go with A12.
Roger, Columbia, we like the APU heater, tank, slant, fuel line, slant, water system, 1A, 2A, and 3A to auto.
Okay, that is complete, Kurt. Thank you.
This is Mission Control Houston. We're 4.5 minutes from losing telemetry and voice through the Eastern Tracking and Data Relay satellite. We will have some ground coverage through the Indian Ocean Station beyond that to cover us for the beginning of the OMS maneuver, which is about just a little under 6 minutes from now. Just a little bit ago, the mechanical systems and booster officers reported having seen during the ascent an indication on the left OMS engine that the chamber pressure in that OMS engine was off-scale low. They believe at this point that that is a transducer reading and that they can't find through all of their other diagnostics any indication that there's anything wrong with that maneuvering engine. Just in case, though, the ground decided to tell the crew that during the course of the upcoming OMS burn they may see some spurious readings on board, and that they should recognize those and understand what they mean. At this point, we're anticipating a nominal burn 5 minutes and 10 seconds from now. Columbia Houston, we're approximately 2 minutes from losing Tidris East. We'll be handing down to Diego Garcia.
Roger that, going to Diego Garcia.
This is Mission Control Houston. We're 2.5 minutes away from the burn. We're 1 minute away from losing telemetry and voice through the Eastern Tracking Satellite. As we do, though, we'll pick up the Diego Garcia ground station located in the south central part of the Indian Ocean, which will provide an additional 8 minutes or so of air-to-ground coverage so that flight controllers here in Houston can look over the crew's shoulder as the OMS maneuver gets underway. We're just about 2 minutes 5 seconds away from ignition.
Columbia Houston, we have you through Diego Garcia, and you're in a good config for the burn.
Thank you.
Columbia Houston, the left engine is good.
We concur.
This is Mission Control Houston with the OHMS burn underway. All flight controllers report that their systems look nominal and the burn is progressing very well. Once again, the left OHMS engine did enunciate an off-scale low reading. That has been determined and proven in the burn here to be a spurious indication, more than likely attributable to a bad transducer. The left engine is in good shape and burning very well.
Columbia Houston, we showed a good burn.
Houston, Roger that, Kurt. We concur, and if you're ready, here comes the secondary and primary gimbal checks.
Columbia Houston, John, we're ready for that. And just a question, did the PC meter work on the left engine?
Negative, it did not.
Okay, thanks, John, and we'll be watching your gimbal check.
This is Mission Control Houston at 48 minutes 30 seconds into the flight of Columbia. Columbia is out of range of all of our ground stations and the Eastern Tracking satellite. We expect to acquire voice and telemetry again in about 50 seconds. Flight controllers who have been here all morning watching orbiter systems on the pad and then overseeing the climb to orbit and ultimately the circularization of Columbia's orbit at 153 nautical miles are taking a very brief break. The next significant event on NASA Select Television will be a post-launch press conference at 11 a.m. Central Daylight Time, coming live from the Kennedy Space Center. Again, our next event will be a post-launch press conference at 11 a.m. Central Daylight Time from the Kennedy Space Center in Florida, just about 17 minutes from now. All systems aboard Columbia are in tip-top shape. The only indications we got from systems on board Columbia during the ascent were false indications. All systems continue to perform very well. The crew is now on orbit and will be shortly configuring their vehicle, the data processing systems, the cooling radiators and payload bay doors to begin the on-orbit phase of the mission. We're standing by now for voice contact through the Teeters West satellite.
Columbia, we're in the post insertion and starting block 1.
Columbia, Houston, John, we copy and we have you back on Teeters West.
Okay, understand we're on Teeters West, so we'll just go with the entire block 1 and keep moving with post insertion.
John, we copy, and again, heads up for Ray, we do have 1 Delta to block 14 as we talked about.
I understand. And okay, she'll come up, calm with you, and she'll get it.
Okay, John, we copy. No rush, just before she gets to block 14 as we know.
Roger.
This is Mission Control Houston. The crew of Columbia is beginning the process of reconfiguring their data processing systems. It's the onboard computers that provide all of the system support and maintain the flow of telemetry and voice, and support all the instrumentations and the computing of navigation and control on board the Space Shuttle Columbia. They'll be transitioning the software in those computers from the ascent and orbital insertion software to the on-orbit operations software. In just a couple of minutes, we'll be switching the satellite back to the Kennedy Space Center for a post-launch press conference coming live from there at 11 a.m. Central Daylight Time. During the course of the press conference over the next 30 or 40 minutes, the crew will be, in addition to reconfiguring their data processing system, will be activating the payload electrical bus, configuring their communications links between the ground and the payload. That is the Space Lab module. And they'll also maneuver Columbia to the payload bay door opening attitude, activated radiators, and prepare the doors for opening. And we, assuming everything goes by the clock, we should anticipate payload bay door opening just about 30 to 35 minutes from now. Columbia, Houston, we also have a Delta to Block 3 if someone's working that yet.
Houston, Columbia, this is Ray, and I'm ready to copy your deltas to blocks 3 and 14.
Okay, Ray, we have a small delta to block 3. We'd like you to add on panel 06 UHF mode to off, and on panel A7 lower ASIP heater to on. And you would also change the pictorials in pages A4 and A8 if you would like. That's all the changes in block 3.
Okay, again, code on 06, you want the UHF to off, and on A7L, ASIP heater to on, and change the pictorials on A4 and A8.
That's a good readback, Ray. And when you're ready for block 14.
14.
Okay, Ray, as we talked about earlier, we'd like you on R12 lower to take the supply water galley supply valve to open, talkback open. And we'd like you to delete from block 14 galley water heaters, 2 of them to on.
Roger, I copy in block 14. You want me to take the galley supply valve to open, talkback open, and you want me on the galley to leave the water heaters, 2 of them, off.
That's a good readback, Ray, and that's from our previous discussion concerning the water tank. Also, I have a change to block 13 when you're ready.
Okay, I'm ready to copy block 13.
Okay, Ray, block 13, we'd like you to add on panel 015, row Charlie, circuit breaker, main B, utility power, F1 slant, ILMO 13Q to close. And also on panel ILMO 86 Bravo, row Alpha, circuit breaker main B, supply water dump ISO to close.
Okay, I copy on 015 row Charlie, circuit breaker main B, utility power F1 MO13Q to closed, and on ML86 Bravo, row A, circuit breaker main B, supply water dump ISO valve to close.
That's a good readback, Ray, and just one other update. We'd like you on ILMF 28 Goff Slant Hotel, that's the EORF. We'd like you to take the alarm disable to up, which should be the enable position, and that's not time critical when y'all get to it. And that'll complete all the deltas right now.
Okay, on the EORF, enable the alarm, got it.
This is Mission Control Houston with everything going according to schedule aboard Columbia. We'll be switching the satellite very shortly to the Kennedy Space Center for our next major programming event, which will be the post-launch press conference coming live from the Kennedy Space Center at 11 a.m. Central Daylight Time.
Welcome to our STS-58 post-launch news conference. Our panelists this morning from your left, this afternoon from your left, are Lauren Shriver, Manager, Launch Integration, and Robert Seek, KSC Launch Director. And we'll start off with Shriver.
Well, actually, today it could be a very short story. As you know, we had a very good countdown. It was very clean throughout from our point of view. Listening to the loops in the background, we had some